So semantics, the gets, the posts, the puts, things like that. The semantics are largely the same in these things here, right? Let's look at some of the most important parts of the request, why we're going to start hacking this stuff shortly. We assume we begin hacking this stuff, right? We have a get, that's the method. We have a URI, we'll talk about URIs versus URLs in a bit, hold that thought. It's a resource, usernums/login.php. We're using HTTP 1.1, okay. And we have a host header with the user agent. The user agent describes the browser. If it's Windows, it also describes the anti-kernel level. We'll talk about the anti-kernel levels in a bit, which is the OS. Right now, it'll say Windows NT 10.0 for Windows 10, but previous versions of Windows like 7, it didn't match the number. The kernel number was different. We'll cover all that. We have an accept language. We can use two forms of compression. There's a refer, and notice that it's spelled correctly. I know that's English is wrong, but that's how RFC 1945 spelled it. If you look at this traffic in Burp or Zap or Wireshark, that's how it's spelled. Here's a response. Okay, 200, okay. It also identifies the server. So the client says, hey, I'm a client. I'm Firefox 67 on Linux, right? By the way, let me show you that before I move on. Evil websites have there's a thing called autopwn. Here's what autopwn does. You surf to evil website. Evil website parses this string. Says, oh, you're Firefox 67 on Linux. And by the way, you're 64-bit Linux, right? I've got an exploit for you. Boom, it's called autopwn. The kid's called ownage now. When I was a kid, it was own with a 0. I owned that thing. Now the kids call it pwnage with a P. It's a video game term that came over, video game term. But the evil web server can parse that string and attack you intelligently based on that string, right? That's called autopwn. There's other things they can do, send you JavaScript for the footprint, the browser. Same with the server. The server saying, hey, I'm Apache 2.4.29 on Ubuntu Linux. Yeah, that's me. Why are you telling the whole world that? You should not tell the whole world that. The browser does not need to know this. You could put any string you want here. The browser won't know or care, right? So I recommend you change these things, and I like to lead by example, so I'll show you one of mine. Go to my website, files@ericconrad.com. Oh, I have to describe this picture to you. This picture has nothing to do with web app pen testing. This picture is Naruto, a monkey in, I think it's Indonesia. And what's happening was, there's a photographer in the wild, and he's trying to teach these monkeys to take their own picture. He's got a tripod set up, a little button you push to take your picture. He's trying to get the monkeys to take its own picture. This monkey walks up and presses the button. So the monkey took the picture. It's a monkey selfie, which has nothing to do with web app pen testing, but I can't not show this face and not tell you what makes me happy to look at that thing, right? So Wikipedia put that picture on Wikipedia because it's public domain, they claimed, because the photographer is a monkey and a monkey can't own copyright. This went to court. PETA sued behalf on the intellectual property rights of the monkey, repeatedly, over and over and over again, to the point of nearly bankrupting the human photographer. It's gone on back and forth for years and years and years. The monkey selfie. So they sued and sued and sued and sued. And finally he settled just to stop them from suing him. This is the human photographer now. So that's Naruto. So I love that story. Now why am I showing you this picture of Naruto? Well, I just have this on my website just to show, there's nothing to see here, folks. This is the place where I upload my papers, or used to before I used Dropbox, but it's still there. Now, anyone notice a glitch in the matrix here? What's wrong with this picture here? Anyone catching that? So I'm running this on Atari 2600, right? At least I'm claiming to be, right? It's really Apache on Linux, right? But I'm not going to tell you Apache. I'm not going to tell you Linux. Why am I telling you that? Why am I aiding the attacker? Why? Right? I want to confuse the attacker and confuse the auditors and confuse the pen testers and make all their jobs harder. All of them, right? Now, I had one student say, well, Eric, you need a more plausible ruse. You're clearly not running it on an Atari 2600. I said, you don't know that, right? I'm not. I had one guy say, what's Atari 2600? I said, man, get out. Get your books and leave, man. You've disappointed me one too many times. No, I didn't say that. For those that don't know, the Atari 2600 was the coolest Christmas gift of 1979. It was the first video game system that took cartridges at home that was popular. Anyways, another guy raised his hand and goes, well, Eric, you should use a more plausible lie like Solaris. You're clearly not running that in Atari. That's not a very believable lie. Make it Solaris. I'm like, you have a good point, but that's boring. I think this is funny. I'm going with this. But you're right. Right? Lead them off the trail, right? But again, why tell the truth? Why? What do you gain from telling the truth? Nothing, right? And by the way, natively Apache can limit that to just Apache. That's called a product string, by the way. Within the Apache configuration, you can just make that Apache, which you should do. However, with mod security, you make that string anything you want. So I use mod security on top of that, right? So semantics. Safe methods, meaning you're downloading stuff. Get, head, and options. Unsafe methods where you can actually change the web servers while they're marked safe. Not that gets are always safe, they're not. But as far as changing the file system directly, it's safer, I suppose. ID and potent methods, that's a tough word to say, yield the same end server state. So get. There's nothing in the body of a get request, so there shouldn't be, right? And all information is shared via headers. Posts act differently now, right? So if you're sending variables in a get, it's in the URL typically. You send it in a post, it's actually in the body of the request. So 2 examples side by side to illustrate this. Get, we're saying, login.php, user equals Zaphod, pass equals Gargleblast, a button equals login. All of those are in the header. Post, same options, but the options are actually in the body of the message. This changes our attacks. These gets are, for beginning pen testers, these are very easy to understand because you can just change the actual URL in the address bar. You just start hacking that directly right in your browser. You don't actually need any extra tool to change that. You can just start changing what's in the directory bar, the bar and the address bar. Here, I have to actually change the body of the request, typically using a tool like burp. So URI query parameters, indicated by the first question mark, and it can be fairly straightforward. And whenever you start seeing things like users, this, we always start hacking this, make that root, make that whatever. If there's UID, always try 0. Always try -1, 0, and 1 for numbers. Always, always, always try a negative number if you're hacking numbers. Always try negative numbers. I've had some amazing findings by trying negative numbers, right? We'll see that later on. To your point, post parameters. Obvious injection point, and burp and zap. Burps, intruder can see this stuff, change this stuff. We can do a sniper, we can do a cluster bomb. We'll talk about all those things coming up. Hack this stuff relentlessly here. So it's burps and parameters now. So it can actually automatically find this stuff for you. So burp gives you a lot of amazing features. It sees a post, it sees parameters in the post, it knows they're there, it actually highlight them for you, and you can start fuzzing. And fuzzing is just sending unexpected input in this case, right? So fuzzing is sending unexpected input, changing the username from Zaphod to root to whatever, and seeing what you get, and using a tool like burps intruder to do that. So method interchange. We can actually turn gets into post and vice versa, right? Called method interchange now. Change request method, burp repeater. Right now, here's the post. Here's the post, here's the options. We change the request method in burp, and now it changed that post into a get, right? This is a killer feature for bypassing WAFs, right? Whoever designed the WAF is expecting this post, right? They're not expecting you to do that. It may work, it may not, but most WAFs are considering this coming in. So okay, if I see a post, and you're trying to write a WAF rule on this thing. If it's a post, the username has to be 4 to 12 characters, mixed case. The password has to be X characters. The button has to be login only. Like you could say, button has to be on a WAF. Now, web application firewall. Button has to be login, that exact string, right? This could be a string up to 20 characters long, whatever, mixed case, etc. This could be a string, but I don't want any single quotes, I don't want any double quotes, I don't want any brackets, etc. You run a WAF rule on that for posts only. Then I do this, method interchange, I flip that post to a get that does effectively the same thing. And your WAF has no code or technology whatsoever to stop that, right? So you get some really killer findings this way, method interchange. Head just downloads, the header, as the name implies. So in the history of monitoring websites, back in the days you would ping the website to see if it was up, but pinging the website doesn't show you the website's up, it shows you that the OS is running and not being filtered, right? So they said, okay, we'll download a page. Well, if you want to prove, is this thing working at layer 7, the data application layer, instead of downloading a page, which is wasteful, just download the header. That's why head exists, right? So we typically do heads just to pull down the header. It's more efficient than a get, right? And there's the head command there. Trace allows the client to see what is being received on the other end of the request chain and use that data for testing and diagnostic information, right? So what if we're going through like a load balancer? What if the web server that I'm scanning is not one web server, but 4, right? I'm scanning 4 web servers. It's got one IP address, it's got one name, but it's being load balanced on the back end. And I do an mmap scan, but essentially, I'm really scanning 1/4 of 4 servers, not all of one. And I run a port scan. It's port 80 open, that's on server A. It's port 81 open, that's on server B. It's port 82 open, that's on server C, et cetera. And then it kind of does this round robin fashion. So I'm basically sampling 1/4 of the ports in each server. I want to get all the ports. And it's important to know when you don't know something, which is an odd thing to say, but it's true. If I issue a pen test report, I've read many like this. We scan the web server, here are all the open ports. No, you don't know that. You really don't know that, right? UDP, you certainly don't know that. You definitely don't know that UDP. TCP, you might, but what if I'm behind a load balancer, what I would normally do, instead of scanning it once, I might scan it 20 times. And then put in my pen test report, we detected a load balancer. There appears to be 4 web servers where it's claiming to be 1, but appears to be 4. We scanned the servers, the IP address 20 times to have a higher chance of getting all the ports, but there's no guarantee we got all the ports. You might be thinking, Eric, what does it matter? You have 4 identical servers. I would not take that bet they're identical. You think 4 servers in a load balanced cluster would be identical. You'd lose that bet a lot of times. Sloppy operations is very, very common, where one's slightly misconfigured, one's slightly older, one's newer, whatever. One of those in there is different, right? We see that fairly frequently, right? Options isn't super useful. Options will just say, here are all my supported options. Trace and post and put whatever. So options will tell me the options, but I also have the option of try to get, try to post, try to put, try to delete, try to trace, etc. So I can just iterate through all of these things. If it tells me head, get, post options, fine. But again, I can just try each of those methods independently and get the same list. So not super critical if that's turned off. We can get that data in other ways. Create, read, update, delete. Okay, that's another way of looking at these methods, right? Creating data, right? R, you're reading. U, you're updating, you're changing data. D, you're deleting. CRUD. So that's the acronym CRUD. I like that acronym. Kind of clarifies our discussion of these things. Now, the user agent. Again, so we have a lot of compatibility stuff, right? Notice that Chrome also says Safari. It does, right? Safari's kind of covered up here. Chrome also says Safari. Why? This is like web compatibility stuff. Some web servers will inspect the user agent and give you different content based on the user agent. Oh, Safari supports this feature, let's use that feature. But it turns out Chrome also has that feature. So the browser will also claim to be Safari to say, I'm compatible with Safari. So we see lots of stuff like that, where you see multiple user agents, where multiple browsers list the same user agent. Most user agents will say Mozilla, but Opera doesn't always do that, because Opera just has to be different. But most user agents, even Microsoft user agents, IE, et cetera, use Mozilla. Why is that? Clearly, IE is not Mozilla, right? So back in the day, when IE came out, well, first you had Mosaic, the first graphical web browser. And then Firefox's code word was Mozilla, the Mosaic killer. It was designed to kill Mosaic, and it did. Mosaic's now quite dead. And Netscape's killer feature was frames. It supported frames, Mosaic did not. So some web developers in the day said, if you see Mozilla, you get frames. If you don't, you must be Mosaic, you don't get frames. You get like a 1995 GeoCities version of something. When IE came out, it didn't say Mozilla, so we got the Mosaic version of the web back then, the old 95. So even Microsoft added Mozilla for compatibility purposes. Most tools will be honest and claim the tool here, but you can change that. So we change things like that all the time. You can simply use a lot of tools, including SQL map right in the command line. You just copy this user agent and use it as a command line option on SQL map. We'll do that later on this week in a lab, by the way. So I can relentlessly lie here, right? And many websites will block SQL map, but not things with Mozilla in it. And by the way, I've seen many, many WAFs say, if it says Mozilla, your browser, come on in. And so if you are setting your own user agent, sometimes the fastest thing, using SQL map or something, just make it Mozilla, that one word. You'll often sail right through. So the refer, this is spelled RFC 1945 way. In fact, this came up. The gentleman who made this typo back in 1995, he was called out on his correct spelling of refer. He said, no, actually, your spelling is incorrect. My refer has been sent over the internet trillions of times. Far more times than the word refer has ever been written or spoken in English. My way is correct, your way is wrong. So he's not backing down. But it's supposed to be, the refer is supposed to have 2 R's in it, right? Well, 2 R's in the middle now, right? Supposed to be another R right there, right? Not important, but it does, because eagle-eyed students catch this. HTML5 spells it the English way. So we see refer spelled a couple of ways. We're actually very careful on doing it consistently. It can be a bit confusing, but there you go. And we've also seen, now do not use the refer as a form of access control. You know, you try to protect this one page. And is the refer coming from the referring page? Well, I can forge that too, right? Let's say I had a WAF saying, okay, you can only get to page B if you come from page A, right? Because you have to be coming from page A. This is page A, it's going to some other page now. So it's going from here to here, right? Here to here. And you can have a WAF say, okay, you can't go here unless this page sent you there, right? That's a very, very weak form of security because I can forge that. You will forge that later on this week. You're going to break into a web calendar through a refer attack later on this week. So get some cookies now, a lot of cookies. So HTTP and HTTP doesn't have any concept of state. How do I know you're logged in versus you're logged in versus you're logged into a bank? Whose session is whose, right? Cookies are one way to do that. There's other ways, session tokens, whatnot. So I can set the cookie, and then the first response says, here's your cookie. The subset request passes that cookie back, right? So the server says, here's your cookie, and the client sends it back. That's one way to track state. You log in your bank, you get that cookie. You got to transfer your balance, you have to have that cookie sent back, right? That's one way to form a form of a session, right? Of course, we'll relentlessly hack cookies as well this week, right? So authentication. There's nothing built in. And we'll discuss authentication in detail later on. And client tries to access a resource without being authenticated. Server responds with 401. And client responds with a populated authorization header, if it can do so, right? So response codes. 100s weren't terribly interesting until switching protocols, WebSockets came out. 101 got more interesting. The 100 ones weren't terribly interesting, but 101 switching protocols is 200 means success, 300 means you're redirected, 400 is a client error, 500 is a server error, and again, the newest one that I'm aware of is 451, Fahrenheit 451. Saying it's being censored, essentially. You can also cache things, of course. Proxies will cache stuff. What gets cached? You go into a squid proxy, something like that. It's caching. So it's proxying your traffic. It's caching data. 3 users download the same file. 1 file gets downloaded locally and then served up to all 3. And these types of things are cacheable, right? And you can status code not modified, rather, excuse me. That's one thing to keep an eye out for. And the browser shouldn't have sent the request as the data was previously cached, and you look for the cache for the content. So if you go to a web server and it's telling you this, it says you've already downloaded that, you should already have that in your local cache, right? You re-downloaded something that's already in your local cache. Once you download a web page, you'll sit in that cache locally on your server for a while, right? Now the response server. Here's a server response. Again, it'll tell you the version of the server. Again, I recommend at minimum as a defender, you narrow that down to just Apache. Because if I know it's 2.4.29 on Ubuntu, I can look up an exploit for 2.4.29 on Ubuntu and launch it. You're helping the attacker. Again, you should not help the attacker. We have basic realm, basic auth restricted. So you serve to a website, and it asks you to log in, and here's the response. Oh, pro tip here. I had a student get a question wrong on the CTF once, and he got visibly angry at me because he kept insisting that the game was broken. He was making a mistake. Base 64 has to end at a 4-byte boundary, right? If you chop off those two and equal signs are used to pad it out. If you chop off those equal signs, most tools won't care. The command line base 64 won't care. Burp will care. Burp will give you the wrong answer. It'll stick a weird character on the end, right? And so he's like, it's wrong, it's wrong. And it was a very sharp accusation to his, his statement. And I'm like, well, let me give it a look. I'm like, listen, over 1,000 students have played this game. I'm pretty sure he's shaking the bugs out, but I'm happy to help. And he's like, look, it's wrong. And he's chopped off these two characters. And I'm like, well, just read the question more carefully. It's wrong. And he's like, what I couldn't say was, hey, you're making a mistake, because now I'm giving you a free hint. We have hints on day 6, but they cost points. If I'm helping you, it's an unfair advantage to everyone else. Other students have figured that out on their own. Why would I help you? I said, listen, I know exactly what's wrong. When the game's over, I'll come over and tell you exactly what's wrong. I'll help you then, but I can't help you now. I hope you understand why, right? So pro tip, use properly formatted. Make sure, don't chop those equal signs off. Keep them in there. Again, most tools won't care. Burp, last time I checked, will.